This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
This Master Brewers podcast is proudly sponsored by Barnett Mechanical, a full-service design build firm specializing in turnkey process and utility systems for the brewing industry. You know beer. We know breweries.
If you go into a pub in the UK and you order a pint of cask beer, you expect it to be perfectly clear. And if it's not clear, you send it back.
This week on the show, Cask Beer. We talk ingredients, process, best practices, and authenticity, all right here on the Master Brewers Podcast.
My name's Marcus Cox. I work for Mindful Brewing Company out of Pittsburgh.
Before you immigrated to the U.S., your brewing career began in Australia. How did you first get into cask beer? Did you encounter a lot of real ale in Australia?
No. So the climate is probably the main impactor there, both in terms of potential cellar temperature and also obviously the ambient temperature. It's much warmer than the UK, so it's not a big thing. But purely by coincidence, was for a super small brewery called Three Ravens, and they had two customers when I joined, and they were both cask customers. So that was 15 years ago. We were the only brewery in that town and in that city selling cask beer at the time.
I guess we should talk about ingredients for cask beers. How about malt protein content? Why does that matter for cask beer?
Well, I mean, there's a couple of things. Again, my perspective is on it's very hard to define modern cask beer, so I defer to the real cask beer that you get, made in the UK at an English pub, maybe in London or something. So that's very much my point of reference for these comments. One thing to remember is that the protein comment is based on the fact that this is a beer that has a very fast processing and doesn't have any chill stabilization. If you go into a pub in the UK and you order a pint of cask beer, you expect it to be perfectly clear. And if it's not clear, you send it back. Tying that in with the protein, the lower protein content obviously ends up with a clearer beer. And in the absence of chill stabilization, it all just makes sense.
Sounds good. And we've learned from some other episodes, especially with Joe Hertrick, about some of the differences in protein content for European versus North American barley. Do you want to comment on kind of, some of the typical ranges you see there, and perhaps, what types of barley are most commonly used in the UK for these type of beers?
Sure. I think over time, the barley market or the barley providers have stabilized a lot of these specifications. So it's probably a little bit less different now than it was traditionally. Obviously, with the American move from 6-row to 2-row in the uptake of craft beer, that's made a big change. But, classically, typically, UK ale malt comes in well under 10%. And this is just a very broad generalization looking at some of the main suppliers like Simpson and Baird's and those kind of large medium companies, where if you have a look at something from Breese, and again, these are very coarse numbers, it's generally plus or minus 12.5% for a 2-row base malt. So it doesn't sound like much, but it is enough to make a difference in terms of clarity. And then maybe to tie that back into brewhouse processing, protein content is inverse to extract. So the lower the protein content, the more extract we're getting. When you're doing an English style beer with a single step infusion in a very simplistic mash tun type situation, you'll take that extra extract every day.
All right. How about hops?
Hops. Well, I mean, hops are a little bit more interesting. And again, looking at a couple of traditional English varieties, Fuggles and the Goldings variants, the thing that really stands out is they tend to have lower alpha and beta acid. So that's something that really, separates them from obviously New World hops and American hops included in that. There's very little geraniol present, higher humulone levels, so there's a particular softness to them, let's say, lower myrcene, and there's generally no beta-pinene present. So this has to be a comparative statement, but the interbreeding of the Neo Mexicanus hops, most likely with American new varieties, has put some of these compounds into the hops. The English varieties tend not to have them and are much more suitable to traditional subtle dry hopping in the cask.
I don't know if you've had a chance to listen, but our guest on last week's episode uncovered literature from 1893, which indicated one of the major reasons for dry hopping was to get those hop enzymes into the beer and encourage a secondary fermentation and dry out the beer. How important do you consider that to the process?
It's certainly not something that's included in, obviously, classical literature. Having seen the presentation at the Eastern Technical Conference a couple of months back, that was definitely one of the things that caught my eye. It's certainly something we see anecdotally currently at Mindful with tank dry hopping. It makes sense, but I don't think all the evidence is there to prove that it has, it just hasn't been substantiated yet.
Okay, what's most important when it comes to yeast selection for cask beers?
There's a couple of things. Anything to do with diacetyl goes out the window. So the position is that diacetyl is an acceptable component of classic English cask beer, so you don't need a heavily diacetyl-reducing yeast. The second component, which obviously is inherently linked to that, is that you need high flocculation. So you're talking about a beer that's going to undergo secondary fermentation in a sideways sitting cask that has to fall about 12 to 14 inches from top to bottom. You need something that's going to do that in a couple of days, so high flocculation.
All right, do you want to comment on the role of Brettanomyces in cask beer?
Again, this is something that was flagged relatively recently by Ron Patterson in some of his writings. So it's again another thing that's just kind of popped up that's yet to be fully substantiated, but it would appear that obviously given the name of the yeast, the time it was isolated, it's inherently linked to the British brewing industry. The concept of at a particular time in England, there was a tax regime that taxed different aged beer differently. The aged beer would contain Brettanomyces is the contemporary thinking.
All right. What about the biggest ingredient, water?
So obviously the breakthrough positioning here is when Burton-on-Trent became the brewing capital of the world. And they're particularly, high degree of sulfates and a back note of Epsom salts of magnesium sulfate generated a really specific water profile that was amenable to higher hopped beers. And higher hopped obviously is a slightly different meaning because you're talking about much lower alpha acids than what we're used to now, but it helped to accentuate the hoppiness of the beers. So basically, once, I think in I've got to check my references, but once the concept of Burtonization was isolated by industrial chemists and brought back to the rest of the UK, that was really the major profile used across the whole country. So the water all these ingredients are super critical, but the water is the one that's the easiest to reproduce because you just have to very simply alter the mineral profile.
I've seen folks use dextrose, honey, wort, you name it, to prime casks. What's best practice and what's considered most authentic?
Most authentic is to leave enough residual fermentables in the cask to ferment itself. Again, it's more anecdotal, but that as you mentioned, the potential for that dry hopping in the cask to spur further fermentation is definitely in the mix. But you either have the wort that the beer is made from, or you have enough residual fermentables in the near finished beer to perform that secondary fermentation.
Coming up.
So that's the trade-off. You're allowing these non-desirable compounds to vent off, and you're allowing oxygen to come in.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas. This episode is brought to you by
ABS Commercial is a full-service brewery and parts outfitter. From our Raleigh headquarters to our Denver office, we proudly offer brew houses and fermenters from 3 barrels and up, yeast brinks, boilers, kegs, chillers, tri-clamp, and other stainless parts, all with the quickest delivery and lead times in the industry. Learn more at abs-commercial.com or call 877-BREW-ABS. ABS Commercial. We are brewers.
I'm really looking forward to the ASBC MBAA Brewing Summit coming up this August in San Diego. It only happens every 4 years, and it's not like any other conference you've attended. The Brewing Summit is 100% the science and technology of brewing. No pep rallies or business lectures, and you'll be surrounded by some of the smartest men and women in our industry. If you can only attend one conference in 2018, this should be it. Register now at mbaa.com. Now back to the show. Talk a bit about timing and temperatures when filling casks, and also that balance of yeast to fermentables.
Sure. So, I mean, these yeasts are relatively high flocculators, which means they're not the best attenuators. So what happens there is that I think while maybe the dry hopping has a contribution to make, the main thing that inspires that secondary fermentation is just mixing the beer back up. It's sufficiently roused in effect to form that secondary fermentation. The secondary fermentation conditioning temperature comes in at about 54 degrees Fahrenheit, and you're looking about 500,000 cells per mil to make that happen. One thing that is really critical with these beers, and I'm probably going off the question a little bit, but this number, this 54, 55 degrees F or something in that range is going to come up again and again and again. The beer is secondarily conditioned at this temperature. It is served at this temperature. It's in the glass at around this temperature. This temperature is the driving force of what happens downstream with this product.
You mentioned a couple of days for settling time earlier. Is that what's typical, or are you typically requiring something different there?
It's going to be in relation, obviously, to the starting gravity of the beer and the residual fermentables available. Clarity is a really good indication of a completed secondary fermentation. There's a very English concept of describing a beer as coming on. So once that secondary conditioning is taking place in the cellar, the beer stays in the same place. It doesn't get moved, and it's super critical. So where it's conditioned is where it's dispensed from. The classic image of a Friday night with the guy running out with the magical little firkin and throwing it on the bar for dispense is a little bit kind of out of the realm for me. So that's what's happening there. 54 degrees conditioning, 52, 54 for dry hopping, which obviously occurs simultaneously to the conditioning. The clarification again at that same temperature, 52, 53, 54, 55. That also lands us in a place where the saturation of CO2 that's been generated from the secondary ferment is perfect for the style of beer, which is about 1.15 gas volumes.
So that's like basically half of...
Yeah, it's less than half a commercial American beer. It's temperature dependent. So because a correct cask beer is dispensed at a particular temperature, and
yeah, you're going to get that. Yeah,
correct. And because it's vented, it's effectively there's a saturation of CO2 in the liquid, which may take it a little bit higher depending on whether the life cycle of the beer, whether it's the first day of tapping or the third day of tapping. But at 0 psi, the balancing point is always going to be that 1.15 gas volumes.
All right, talk about the role of oxidation in cask beer. Is it all negative, or are there some benefits too?
Well, I think there are some benefits. Obviously, anything that undergoes a secondary fermentation this rapidly is going to have some aromatic compounds that are not necessarily desirable. So that's the trade-off. You're allowing these non-desirable compounds to vent off, and you're allowing oxygen to come in. A lot of these beers are crystal malt forward, so you're talking between 5, 15, 20% crystal malt. And that's probably the most reactive compound in there that's going to oxidize. The shelf life of these beers is so short that the benefits outweigh any negatives from the oxidization. And again, this is an anecdotal, but there's a curiosity that a cask is sideways. It's basically a barrel of beer lying on its side in appearance. This is very beneficial for the precipitation of the yeast during the secondary fermentation, but I think deliberately it allows a greater surface area to interact with the oxygen and to allow the beer to mature, even if it is a very brief period of maturation when it's open.
What about dispensing? There are beer engines and gravity taps, cooling jackets, widgets, and all kinds of other accessories. What's most important, and maybe comment on authenticity versus quality?
So I'm actually going to bundle authenticity and quality together. I will put the caveat on this that in the UK, breweries tend to be medium-sized and very regional, and it's a little bit different to here in the US. There's a tied house system where breweries physically own a lot of the pubs that their beer's dispensed in, so it's in their best interest to present them in the best way. To keep it simple, I'd subscribe to the camera definition of cask beer, so the campaign for real ale, and say that gravity dispense is great, beer pump dispense is great. Any extraneous CO2 that is put into the cask at any point takes it off the list of an authentic cask. The bottom line is a lot of the beers I've seen in the US described as cask beer by this definition are not cask beer.
Makes sense. What are the most common mistakes you see brewers making when attempting cask beers?
I think it's a very delicate balance. I mean, the biggest challenge probably faced in the US is that there isn't necessarily a market for cask beer. So you walk into a pub in London and they're going to have a number of casks on. They're probably owned by a brewery. You're going to have your selection of 4 or 5 different beers, and they sell in those very brief timeframes of 3 to 5 days when the beer's at its best. So over here, that's not necessarily the case. So without that, without that history and without that kind of commitment to cask beer, it's very challenging to find cask beer in fresh condition in the US. And often you see it kind of fashionably dosed up with extraneous things that maybe don't belong in cask beer. During the Victorian period, it's obviously the pinnacle of cask. And up until 1880 in the UK, there was a tax on malt. So very quickly, brewers prior to 1880 in the UK, which is obviously the kind of birth time of cask beer, were very amenable to using non-malted products. Obviously, with access to the Caribbean, a lot of sugars came into the mix, using non-malted products, using maize and stuff like that. There is a tradition of using not just all malt in cask beer, but as I said, it doesn't necessarily extend to these other crazy things like banana purees and that kind of stuff.
Probably the number one thing you hear from folks unfamiliar with cask beer is, who wants to drink warm, flat beer? How do you respond to that? How do you describe the romance of real ale?
It's a very difficult thing to describe. I was making cask beer before I'd ever been to the UK, and I was working with I had the pleasure of meeting Roger Probst, and he came and visited me in Australia, and he gave me a lot of hints and tips on how to make cask beer better. You don't know the real experience until you go to the place. So it's obviously body, but cask beer is something you walk into a pub, you drink it, it's a pint, it's not very expensive. People that are well-dressed, people that are not well-dressed are drinking it. It's just what everybody drinks in the UK. It's all about the experience. Cask beer is, even with the wonderland that is the UK, it's heavily in decline. It's the camera, the body that drives the organisation of cask beer from the consumer level has dropped from about 200,000 members down to about 160,000. Cask beer is an anachronism. It's not necessarily best defined as a contemporary product. It needs a way forward. It needs to make friends with craft beer, and they need to find a middle path where craft beer and cask beer can coexist both here and in the UK with slightly different contexts.
That was Marcus Cox here on the Master Brewers Podcast. Marcus is a member of District Pittsburgh, which was recently resurrected. Now, here's a message from the district president.
Hi, my name is Dan Yarnell. I'm a brewer over at Rivertown Brewing in Export, Pennsylvania, just outside of Pittsburgh. I've been brewing professionally for about 8-9 years now, and I am the president of the local chapter here in Pittsburgh for the Master Brewers Association of the Americas. Initially, the MBA started in Pittsburgh in 1935 and then went defunct in the late 2000s. So we've had about 10 years where there's really nothing, so to speak. We were taken over by the Philadelphia chapter, and then earlier this year, I believe it was February, that's when we did reinstate the chapter status. So for any brewers out there that are in kind of the Western Pennsylvania and they're looking for a local chapter, please contact us via either Facebook or through the MBA website, and all the contact information would be right there.
Well, I can't get stuck, I can't be losing too much, and then I'm heading out to any other place. My fist full of courage, my heart full of rage. Well, I can't get stuck, I can't be losing too much, and then I'm heading out to any other place.